Hello, and thank you for joining my session. I'm very excited to take you through an intro to JavaScript Robotics. We're going to be doing a lot of Node.js demos today, and I'll be sharing a lot of code examples that you can use yourself, as well as going over some devices. So without further ado, let's get going. So a little bit about me first. I'm a technical evangelist at Microsoft. That seems like a bit of an odd term, but essentially it means that I get to work with both startups, businesses, and communities to utilize Microsoft products and technologies to make their day-to-day life a lot easier. So that's a really, really rewarding job. On the side, I'm an open source hardware author. Most of the open source hardware libraries that I contribute to or maintain are Node.js, which is why I'm bringing you a lot of this today. And I'm also a member of the Node.js hardware working group. This working group is very passionate. We're a very diverse, lovely bunch of people, and we tend to work on things like global education of Node bots or Node robots, as it's known as. And we also try and campaign to have things like serial libraries and stuff like that to become first-class citizens within Node Core. So we're still working on that, but we tend to be the go-to people if you have any questions about Node bots or Node robotics itself. A bunch of us also came together and we wrote a book a couple of years ago, and it's called Make JavaScript Robotics. It's published by O'Reilly, and there's a lot of us on the front cover of this, and we all contributed a chapter each. And so it's a very, very diverse group of projects that you can work on. It's everything from really cool Node boats to things like musical shoes, which I'll go into a little bit in a sec, and even remote control cars and security systems and all sorts of really fun stuff. So if you like what I've been talking about today and you're really, really excited to get stuck into some projects but don't quite have the ideas to get you started, then this is a really great book to pick up. So the chapter that I contributed to this book is all about making your own meow shoes. These shoes, other than just having cat faces on them, they also allow you to tap out songs in a web browser interface. And so this connects via WebSockets with Node.js, and you can essentially dance your way to sequencing up a tune. One of the different kind of instrument voices that you can choose is a cat meowing, and so that's where the name came about. But essentially they have pressure sensors in the heels and toes, as you can see in this image, and as long as you're standing or just dancing in general, you'll be able to generate those sounds, which is really, really fun. So I tend to like to create really fun and engaging Node bots, and they tend to be less serious than others might be. So moving on to another project that I did a couple of years ago, I also created the PUR bracelet, which stands for the Personal Ultimate Reassurance Response. And essentially it has a pulse sensor that measures the pulse on your wrist, and it has a Wi-Fi microcontroller in there which can connect to the internet. And it measures your pulse for extended periods of time. And if it notices that your heart rate has been elevated for a few minutes, it's going to assume that maybe you're not exercising, but you might be having a panic attack or an anxiety attack. And so if it gets those elevated heart rate readings, it will start to text you pictures of kittens to your phone to let you know that, hey, you should probably breathe, look at these relaxing photos, and it's going to be okay. And so I created that for a hackathon for AT&T, and it weirdly got a write-up in Fast Company, which I was not expecting because it was just a fun project, but that's really cool. And so that's just sharing a couple of the projects that I've done with Node.js and robotics. So I'm going to take you through more of an introductory level stuff, but I've also got another new project that's really fun to show you towards the end. So the agenda for today's talk, the first thing I'll take you through is an introduction to 3 different microcontroller boards, and we'll be working with them in the demos today. I'll also take you through what inputs and outputs are in conjunction when you're making with robots. So, what does that mean exactly? Then I'll take you through 3 different approaches that you can use to use Node.js with robots and electronics. The first one will be Node.js on the board itself, on the microcontroller. The second one would be Node.js off the board, so that could be running on your local machine, but it's controlling the hardware. And you can also use Node.js as an Internet of Things service, which is slightly more advanced example, but I wanted to show you some of the more involved stuff that you can do once you're used to doing some of the more introductory stuff. Then I'll have a slide just covering some resources about all of the libraries and microcontrollers that I covered in the talk today. So first of all, when you think about robots, like, what do you think of when it comes to what they're made up of? I tend to think of 2 things pretty quickly, other than, of course, nuts and bolts and futuristic looking metal. I think microcontrollers, which tends to be the brain of the robot, that's what controls it, and that's what decides on its behavior, essentially. So if we are going to think of robots in terms of likening them to humans, we would say the microcontroller is the brain. The next thing that they're made up of is inputs and outputs. And so a robot needs to get some kind of outside stimulus in order to then take that and do something with it. So again, if we're likening robots to humans, if a robot has been programmed to have some kind of sight, or it can perceive its surroundings, with sight, such as a webcam, it can take that as an input, and then it can decide to maybe move around an obstacle. And so I guess that's what I mean by inputs and outputs, but we're going to go into a little bit more detail as far as specifically what they can be for robots, other than the example that I just gave you then. However, let's talk about the microcontrollers first, and I'll go through 3 very different microcontrollers. The first one, which a lot of people have probably heard of, it tends to be the one that everybody starts with. It's the Arduino Uno. Arduino is a company that's been around for many, many years, and they popularized the affordable, easy-to-use microcontroller. And so this is an oldie, but definitely a goodie. It's a great one to get started with. Just some information on the tech specs, though. Its processor is an ATmega 328P. That's a bit of a mouthful, but essentially what it means is it runs at 8 megahertz. You heard right, 8 megahertz. So it's not lightning fast, but it gets the job done. It has 32 kilobytes of memory. So that's where the 32 or the 328 comes from in the name. You primarily program it with C++. So stay with me. You might be wondering why I'm introducing this when it doesn't run Node on it, but I'll cover that later on. And you can pick it up for around $24.95 USD. You can, because this is open source hardware, which is awesome, you can get cheaper off-brand versions of it. So if you are on a budget, or if you have local distributors that sell their own version of it, then definitely take advantage of that as well, because they work in pretty much exactly the same way, and they also run the same software and bootloader. So that's great. So what are these particular boards good for? Well, they're good for offline simple projects. You can put them on the internet, but it requires you to buy like an additional plug-in module that kind of plugs into the top of it, which is known as a shield, because that's kind of what it looks like once you've plugged it in. And these modules can cost from 50 to 80% of the price of the Arduino Uno board itself. And so you will pay a lot extra up front just to get it on the internet. And when you think about it trying to interface with like the HTTP protocol and deal with the packet sizes and things like that, 8 megahertz is not a lot to work with. And so you will find that it may be a little bit slow. You may run out of memory very quickly too at 32 kilobytes. And also it can't handle secure connections. It obviously doesn't have the processing power to crunch on encrypted information, and so you will find yourself out of luck there too. But for offline simple projects, it's wonderful. There are so many C++ libraries out there to get started with it, and there is an incredibly popular Node.js library that interfaces directly with it called Johnny 5, which I'm going to go through in the demos later on. The next microcontroller, which I feel is really important to mention, is the Tessel 2. The Tessel 2 is an open project as well. It has a much beefier processor, so it is still a microcontroller, but it does couple a few different brain chips on the board in order for you to leverage lots of different functionality. So it's a super beginner-friendly device because you don't have to write C++ for it. So if you only know JavaScript or Rust, you don't have to learn a new language to use it, which is great. So it's got a MediaTek chip as the main brains behind it. It's 580 megahertz, which is a huge jump up from the Arduino Uno. So if you want to do more processor-intensive stuff, it's great for that. And again, you can use Node.js and Rust. It has 32 gigs of flash memory and 64 megs of RAM, so that's plenty to be able to run something like Node.js, which is great. It is a little bit more expensive than the Arduino Uno. It's around $45 USD, but you do get a lot of bang for your buck in this case. There's a lot of really cool stuff. It connects via Ethernet and Wi-Fi. It has USB ports, so you can additionally support Bluetooth if you would like to, which I think is really cool. And it does actually run Linux under the hood. So it's running OpenWRT, which commonly you'll find on things like routers. So if you've got any routers at home, there's a pretty good likelihood that it's running the exact same flavor of Linux as this Tessel 2 runs. So it's pretty cool. And what that means is that you can use this microcontroller as a wireless access point as well, which has been supported by Tessel through a library written for it, which was written by Nick Herr. And so definitely check that out. It means that you can essentially have this server web page, and as soon as people connect to this device, you can have this web page pop up. And so when you think about it, there's some really, really cool scenarios that you can run on this board. But you can also plug hardware into it and sensors and really cool outputs as well. And so it's a really, really good all-rounder. I would recommend getting started with this one at first if you're just interested in running Node.js untethered on the actual device. So again, it's good for online stuff. It's really, really great for that because you can do stuff securely, and it's also great for more processor-intensive stuff. So if you're trying to crunch a lot of data, or if you're trying to read streams coming from either online or from the USB serial connection, it's really, really great for that because it's super fast. So definitely consider using this particular microcontroller if you're just getting started. And lastly, I wanted to also briefly cover the ESP8266. Now, it's got a bit of a cryptic name, but again, you'll kind of get to know this as you're working with it, and you'll just start calling it ESP8266 and not think anything of it. So the processor is actually a 32-bit processor, which is fantastic. It's 80 megahertz. So it does run at, I think theoretically 10 times the speed of the Arduino Uno. It has 1 megabyte of flash, which is great. And you can write either C++ or Lua on the device directly. So it does have support for several languages. If you've never touched Lua before, I wouldn't say it's JavaScript-like, but you'll probably have a pretty good time transitioning from JavaScript over to Lua. So I would encourage you to give that a go if C++ scares you. The biggest advantage of using this board here is that it only costs $5. And it costs around $5 by itself, but usually we recommend that you buy a breakout board version of it, and I'll go into that when I go over the gotchas. But usually that's only a couple of bucks extra. So if you're looking for a really great board that's powerful enough for most of the stuff you want to do, then I would recommend picking up one of these. So it does have built-in Wi-Fi. That's the whole, I guess, appeal of this device, is it's so cheap and you get built-in Wi-Fi. It is capable of TLS. Currently, there are libraries out there for TLS 1.1, so that's pretty good. You are going to see some encryption support there if you'd like to keep your Internet of Things devices private, and I think that's really important to consider. They are really good for obviously online stuff. For portable things, you can't tell from this photo, but it's about the size of a postage stamp. which is much, much smaller than the Arduino Uno and the Tesla 2 that I went over. So if you're sort of ready to create something that looks a little bit more professional in terms of having a smaller footprint for the device, then definitely consider using this microcontroller. It's great. It's also great for low power. It doesn't use a ton of power. You can usually power it off a small LiPo battery, and they usually cost about $7 US to buy, and you can comfortably run a 3.7 volt LiPo battery as the power device for this, and at about 500 milliamps, you're going to get approximately 6 hours without even going into sleep cycles. And so you can get this to last weeks if you are able to build in some deep sleep cycles into your code, which is fairly straightforward. There are a lot of online resources about that. So yeah, it's great for low power projects. It's going to last a long time. And I just love how tiny and cheap they are as well. The only drawbacks is that they can be a little hard to work with. For example, it doesn't have a voltage regulator built in, and so it's really easy to fry them. So that's why I would recommend looking for a breakout board. One breakout board that I'm a huge fan of is the Adafruit Huzzah A266 breakout, and that costs just under $10 USD, and so it's not a lot extra money, but it has a built-in voltage regulator, and it also just helps you break out those pins, and it allows for easy battery plug-in as well, because it puts the power and the ground right next to each other on the breakout pins, which is great. Another disadvantage of this is that this particular board only has one analog input, and so if you're looking to plug multiple sensors into this device that all run from like an analog kind of technology, then this board might not be for you, or you might need to use lots of separate boards. So definitely keep that in mind. This is probably better for things like I2C projects, which is a communication protocol that a lot of sensors use, or if you're looking to just use lots of lights and things like that in your project instead, which I have a project to show you that uses lights in this specific example. So yeah, that's the 3 most common devices that I tend to work with when I'm doing NodeBots, and so I hope you find a microcontroller that fits your needs from that list. And what I'm going to do next is cover the inputs and outputs before showing you a demo of each of these devices. So we've covered microcontrollers, but let's look at this inputs and outputs thing that I keep talking about. So when you're creating a project, you tend to want to sort of, the best way to get started is to take an input and somehow do something in between and make it an output. And so let's cover inputs first. I tend to think of inputs as read-only. That just helps me remember what the purpose of an input is. So an input can be things like switches, sensors, or even incoming data. So it's anything that you're going to process on the device, and it's anything maybe about your outside surroundings that you want to influence what your electronic robot does. And so a few specific examples of what these could be is you could have a light sensor that senses how much light there is in the room. You can have a humidity sensor, which senses humidity, obviously. You can have a touch sensor so that if somebody tries to pick something up or anything like that, you can immediately trigger an action to happen on that touch, which is pretty cool. But you can also have an API response as the input, right? It doesn't have to be like a fancy sensor that senses outside, environment stuff. You can even call something like a weather API, and that's going to get your environmental data, but you don't have to fiddle with sensors or anything like that. You can get the local temperature, for example, or the local humidity, and feed that into the microcontroller's program in order to deal with that as an input. So that's also an option. Let's look at outputs as well. So outputs I like to think of as write-only. That's not always the case, but most of the time you're essentially sending power to this device, or you're giving it instructions. And so that's kind of why I think of them as write-only. So outputs can also be data. So let's say you take API data and then you do something else and then you just output the data in a different format. That is theoretically an output, so definitely don't think again that you have to have these physical cool things plugged into your machine. You can also just have data as a serial output or as a post to a storage solution in the cloud. So you can take environmental data and store it in a table somewhere. Outputs can also be things like state. So if you have your TV on standby, for example, you're going to see a different colored LED light. And then if you turn it on, that LED light might change to give you the state of the actual TV, whether it's on or off or on standby, right? So that's what I mean by state. And movement, you can also use movement as an output, so you can get your robot to actually go somewhere, or you could get your robot to do some work for you. So let's look at some specific examples of what I mean by these separate points. An output example, as I covered with the TV example, is an LED or a light. That stands for light emitting diode. You can also use a motor. So let's say somebody pushes a certain button on the robot, and you can turn the motor on and it can just start running away from you. So that's an example of using a motor for movement. You can also have a speaker as an output. So let's say you want to have a remote control car that you're building. You can put a little speaker or a little buzzer on it, and you can have that act as a horn, which can be really, really fun. And as I covered on the previous slide, a data stream can also be an output. So definitely consider that, because having a really tiny device posting data can be a really, really useful scenario. All right, so let's cover a few more examples beyond what I just kind of briefly touched on, just to get your imagination going. Again, I try and think of this input-output thing as a recipe. And so you take an output, you take an input, and then you try and figure out the thing that your program does in between in order to kind of translate the input into a really interesting output. So one example I like to think about is using a photoresistor, which is a light sensor. And then you can also connect an LED to your microcontroller, and you can make it so that you can create a nightlight. And so if the light sensor reading gets to a certain low point, which means that it's getting dark, you can now have this LED turn on, for example. And so that's basically exactly how nightlights work if you've got them installed in your house. And you can also do something like the LED might shine as bright as it is light outside, so it's almost like a light reading device. So you could also do that, which could be super fun. Another example is to take something like a microphone, and pictured right there is a really cool microphone breakout that you can get from SparkFun. And what if you took the sound levels in your environment and you spun a little turbine or a propeller, you know, depending on how loud it is in the room. And so I think that would be kind of cool, just so that maybe in a bar, if the volume gets too loud and the turbine starts spinning really fast, you know, you can kind of like see how loud it is. I think that's kind of cool. Another example is something like taking some weather data, which I covered before. So what if we called a weather API, got the local precipitation and precipitation probability for the area, such as is it raining right now and how much, and what's the probability that it's going to rain later if it's not already raining. And you could use that to make decisions such as turning a watering system on, or changing the schedule for an automatic watering system. And so this can really free up a lot of kind of human resources, and it can take away the need for someone to be on site while they're managing or maintaining a garden, which is really cool. And this is an example of a real-life project that I worked on recently as part of my role as a technical evangelist. I was helping a really cool public garden try and set up a scenario like this so that they could have a little bit more freedom from their watering schedule. So hopefully those examples helped you and helped you get your imagination going. Now I'm actually going to go over more of the technical code side of things and the different techniques that you can use to use Node.js with robotics, because there are quite a few different scenarios that you can do. And so the first one that I'm going to cover is running Node.js on the board itself. So if you remember from the board overview I gave earlier, the Tessel 2 is our ideal device for that. And so let's have a look at some Node code that allows you to be running Node.js on the device. So you can run npm install the Tessel 2 CLI. That's usually the first thing you do, and then you get your Tessel set up and on the Wi-Fi. You install any modules that you might be using, and so I'm going to show you this in the webcam really soon, but you can actually run, you can plug in modules that mean that you don't have to make complicated sensor circuits yourself. And so that's one thing I really like about the Tessel ecosystem, is you can DIY or you can buy these pre-made modules, which is great. And so as you can see here, the code is fairly straightforward. You require the Tessel library, you require the modules library that you're using. There are 2 ports that you can plug modules into, either port A or port B, and then for the ambient module, which we're using today, you can essentially just call get light level and get sound level, and it will give you that because the ambient module has a sound sensor as well as a light sensor on it. So I wanted to show you a really quick demo of that working so that you can see just how quick and easy it is to get up and running. So I'm going to switch to the webcam and so you can see the device, and I'm also going to switch to my terminal. So in this directory, I have just ambient.js, which looks very similar to the code example I showed. The only thing is that the get light level and get sound level are actually asynchronous function calls, and so I have just put in a little bit of extra code there. But it looks very, very similar when you have a look at it. And at the end of it, I'm actually console logging out both the light level and the sound level. And the clever thing about Tessels is that when you console log something, even though Node is running on the actual Tessel device itself, there is a really nice bridge where it will write that console log out to your actual console. So as long as you've got that connected via USB, you actually get that built in, which is really awesome. So I have a Tessel that is currently plugged in, and so if I run Tessel list, you will see that come up. You can see a light coming on. Might take a little second. Looks like it froze. Let's give it another go. Great. Okay, so that's my Tessel that's being plugged in by USB to my computer. And then if I just want to run a specific JavaScript file or Node.js file on this Tessel, then I can just do T2 run and then the name of the JavaScript file, which I just cut it out for you there. So I'm going to hit enter and wait for that to upload. So this is the Tessel here, and the ambient module is this little square that I've plugged in. And what's happening right now on the command line is it's taking my program, it's taking all of the Node.js, the Node modules, and it's zipping that up and sending it over the wire. And you can also do Wi-Fi deployments as well, which is really cool. And it deploys it, it unzips it all, it sets it all up, and it starts running it all for you. And as you can see here, the light level and the sound level are now coming through. Now the sound level is probably remaining at the same level at the moment because I'm talking, but if I was to be quiet, then you would see that sound level would drop down. So this is pretty great. I think it's maybe, I didn't count, but it's probably around 20 lines of code, 25 lines of code. Just to get up and running, and so that's really, really cool. And so you can do all sorts of stuff with this, and you don't even have to just be console logging back out. You can be then feeding those sensor values into something else, which can be really, really useful. And another cool thing is you might think that you're just limited to having to run this tethered. If you run the command T2 push and then your file, this will actually push it onto the device itself and run it. So if you then untether this Tesla from your computer, you run it on an alternative power source, which again could be just USB plugged into a wall outlet, you can have your program running, and you don't have to have any other computer like your laptop having to influence it or run the code for you. So that's pretty awesome. You have two different options, and so I wanted to make you aware of that as well. So that is an example of a Tesla up and running kind of hello world. And the ambient module is one of my favorite things to use because you do get two sensors built into it. So yeah, definitely think about giving that a go. Node.js offboard is the next scenario I want to cover really briefly, and that's with the Arduino Uno. So again, the Arduino Uno does not have Wi-Fi. It doesn't run Node.js on it, but if we upload a special script called Fermata, you can actually just start remote controlling the Arduino, because the Fermata code will act as an API for all of the different kind of pins and locations where you can plug hardware onto the board. So I made a CLI tool called Fermata Party, and the name maybe not suggesting what it does, but essentially what Fermata Party does is you can install it as a global CLI tool. You can run it with the name of the board you're using, and then it will just automatically upload the correct version of Fermata onto your board, so that you can get up and running and not even have to open the Arduino IDE, and you don't have to know any C++. Like, you can just be completely removed from that process. Once you've uploaded that special script, we can use Node.js to talk to this board, and secretly it's using the MIDI interface, which is kind of awesome. So the Fermata protocol uses MIDI, and we just send opcodes to the board, and it knows how to interpret them. But instead of having to do that manually, what you do use is an excellent library called Johnny 5. And Johnny 5 can interface with so many different boards, including wireless boards, so you're not just limited to being tethered with standard Fermata, but you can also use a myriad of different boards as well, including the Tesla. And so with Johnny 5, I just require that library. I generate a new board. Once that board is ready and that connection via USB has been established, I can create a new LED and tell it that I've plugged one into pin 13, for example, which is usually the hello world of Arduino boards. And then once I have that object back, I have all of these really cool methods on it, such as strobe, on, off, and in this example, I have blink. Now, the number that I've put as the argument in the blink method is the amount of millisecond delay I want in between it turning on and off. So it will blink at a rate of 500 milliseconds. So let's really quickly go back out into my terminal and the camera so that you can see this code running. So I'm going to go into my Arduino directory. I'm going to show you what's in there. So I have node modules and a package JSON, and that's because I've installed Johnny 5. That's pretty much the only library I've installed. So this one is super lean to get going with. If I cat out the blink script, if I'm not a fumble fingers, you will see that it's the exact same code that I just showed in my slide. So you can look at that code while I run the rest of it. Now, the way to run this is it doesn't have its own command line tool, so it's like pretty vanilla, which is nice. I can just run node blink, and if I find my Arduino on my desk, I can show that to you. So here's the board itself. I've plugged an LED just into pin 13 right here, which again is a very common thing that you would do when you're first getting started. And as soon as I hit enter, what you'll do is you'll see this LED blink just because it is connected to the main kind of system, and it's going to blink the Morse code of the Fermata version that's running on this board, which is kind of cool. I went ahead and ran Fermata Party on this beforehand. But once that's finished with the Morse code, you'll see it'll start steadily blinking once the board is started up. So let's get that going. All right, so there was the Morse code right there. And there is the steady blinking. So that's the code that I wrote right there where it says LED.blink 500. And then if we were to increase that number, it would blink slower. And then if we were to decrement that number, then it would be a lot faster. And so that is a really quick way of using an output. Johnny 5 has a lot of really cool built-in classes for using outputs as well. So you can control motors and piezo buzzers and just lots of really, really cool stuff like screens, LCD screens, like the possibilities are endless with Johnny 5. So I definitely encourage you to get started with that if you're looking for a less powerful device. And then I can just Control C that just to exit out of the board. Great. So the last scenario that I wanted to cover, which I won't go into too much detail about, but there is a GitHub repo that you can look at, is using the last board that we covered in the microcontroller overview, which is the ESP8266. So I made this device called the IoT Tiara recently, and essentially what it does is it's a 3D printed headband, and the crystals are also 3D printed along with the enclosure box. And it has an ESP8266 inside that enclosure with a LiPo battery. I don't have the cover on there, so you can kind of see like how everything is sort of jammed in there. And it uses RGB LEDs for the lighting. And the reason I made this is because I run an almost weekly Twitch channel where I do live coding, and I wanted my viewers to be able to type different hex color codes into chat and then change the color of my tiara live. And so Twitch is all about that live interaction with the person's channel that you're viewing, and so this gave people an opportunity to interact with me in real life beyond just chatting in the IRC chat channel that they give you on Twitch. And so this connects to an MQTT broker, which again, I don't have a lot of time to go into detail on this, but MQTT is a low latency messaging protocol that's usually used instead of HTTPS for devices. So it's great for sending really lean, small packets. And so using MQTT was perfect for this device because I essentially send 3 characters or 3 bytes to the device at a time. The first byte is the red value, the second byte is the green value, and the third byte is the blue value. And so the board can then receive that via MQTT, and I essentially create a Node.js interface in order to control that. So if you want to see that as a demo, then definitely check out the YouTube link that I have there. And if you want to know more about MQTT, definitely give it a bit of a Google. And if you wanted to set up your own broker instead of using something like Azure IoT Hub, which I used because I love it, it's a super quick and easy approach to get up and running with MQTT, then you can actually create your own. There is a package by Matteo called Mosca, and that allows you to set up your own broker and host it elsewhere. So I can show you a quick demo of it, but if you do check out the YouTube video, you can see people are typing into my chat on the bottom right there, and it's changing the color of my tiara. And I live coded that in front of everybody, which was super, super fun. So this is kind of how it works. I have a Node.js app that's running just in the cloud, so you can host that as an Azure web app, you can host that as a DigitalOcean droplet, you can host that on AWS as an EC2. It's really up to you. I love using Azure web app because it's really, really fast to get up and running because you can deploy directly from a GitHub repo, which I love. It's so lazy, and I love that. The web app listens on the IRC channel with the Node.js program that's running, and if it gets certain commands, then it will package up that 3-byte buffer, and it will send that through the Azure IoT Hub, which my Tiara connects to via Wi-Fi and MQTT. And so that's sort of the workflow on how it works, and I do have the instructions on how to set this up in the repo. But I wanted to show you a really quick demo of it up and running today, and that is to change it around a little bit. Instead of using Twitch, you can use a color picker HTML page that someone can access on their phone. That connects via WebSockets to a Node.js backend that's like serving the HTML file. And so again, you can run that on just anything in the cloud that you normally do your hosting with. Again, I hosted that on an Azure web app, and that essentially listens on WebSocket for color commands coming through from people's phones where they're pressing the actual color buttons on their interface. And once that comes through, we produce the exact same 3-byte buffer. We send that through Azure IoT Hub, which can then connect by MQTT to the Tiara in order to change the color of it. And so I'm going to show you a really quick demo of that as well. I have the camera here, and this is the tiara. It's harder to see the lights just because the lighting in here is quite strong. But this is sort of what it looks like. This is what it looks like with the enclosure on there. And I can bring up a web page, and I'm just going to bring that up really quickly right now and refresh it. And if the demo gods are smiling on me, then I should be able to show you an example of that. So the app looks like this. It has different colors that you can choose from. And then let's say I want to change this to red. I'm going to press the red button, and you can see that it magically changes to red. And then if I want pink, I can hit that, and I get pink. I can hit orange, and that changes to orange. So the colors are a little bit weird on this webcam, but let's try green because that's going to be pretty obvious. Yeah. So if I hold that up there, you can see that it's green. And so that's an example of how you can just have Node.js running in the cloud, which you're used to doing, instead of with hardware. And, as long as you have a little bit of C++ or Lua knowledge, you can take the buffers that come through or the messages that you send via Node.js, and you can have the code running on that ESP8266, interpret that, and then control the hardware. So this is a highly engaging and really fun and interactive way to use Node.js in the cloud. So that's why I made the tiara, because it's really fun. So I now wear that on my streams so that people, if they get bored of what code I'm explaining, they can just go and play with the tiara instead, which I think is really, really fun. And that's about all that I had to cover today. But just to recap, we went through 3 different scenarios. We had Node.js running on the board, which is with the Tessel 2. There is Node.js off the board with something like an Arduino Uno, or there are a lot of other devices, again, that Johnny5 can interface with, so check them all out. And I also covered Node.js as an Internet of Things service, which is more of the advanced steps if you're ready to take your training wheels off after trying out the other approaches. But I highly recommend it because it's a really, really fun way to get going. So I have some resources for you related to all of the topics that I covered today. You can go to tessel.io to get started with the Tessel and to find places to buy one. You can go to arduino.cc to get up and running with Arduino, the Arduino platform. I order a lot of my hardware from Adafruit because they are local to me in New York City, so their shipping is really fast, but they have an amazing amount of really cool hardware tutorials on their website. So I would definitely recommend checking them out no matter which microcontroller you want to get started with. They are super cool. And I bought a lot of the parts for my tiara from Adafruit, including the ESP8266 breakout, which is the Hazard breakout. So definitely check that out. Nodebots.io is where to go to if you want to find us as a Nodebots community. Most of the Node.js hardware working group is part of that community too. If you go to that website, you'll find information about just how to get started, our Gitter channel, and getting started with things like Johnny5 and Tessel. Johnny5.io is the website to go to get started with Johnny5. If you were interested in things like the Azure IoT Hub and the Azure Web Apps and how easy it is to get up and running with that, then I've dropped in a Microsoft link there, which has lots of different projects and tutorials that you can get started with. And if you want to know more about the IoT tiara, or if you just want to dig into the source code, which I know a lot of you are super excited about, I know I love doing that with people's projects, you can go to github.com/IoT-tiara, and I also have one called IoT- I think web app or color picker. Anyway, if you go to my GitHub profile, you can and search for IoT, you'll see the app that I used on my phone today. There is a repo for that for you to go through as well. So I wanted to thank you so much for joining me on this presentation today. I hope that it's whet your appetite for getting started with hardware. Let me know what you think, and I hope to see you in the Nodebots community really soon. Thanks.